Hello, I'm Joseph Foley from the University of Southern Queensland in Toowoomba, and we're here today at Milo to talk about irrigation performance.
Dr. Malcolm Gillies, also from USQ in Toowoomba, and here to talk to Joseph Foley about what's happening in the field here today. So Joseph, we've got a few things happening at Milo here near Moree today. I just wondered if you could tell us what you have in the field and what they're doing, those sensors.
So with the team here, we've been able to put out advanced sensors and also a water level sensor from EnviroNode, where we've been able to pick up with the water level sensor that depth of water in the head ditch. That information is used to tell us about the flow rate in through the siphons. The advanced sensors are then set down the field at intervals of a couple of 100 metres, and those are then used to ping out to the system to tell us when water has reached those points in the field.
How long is the field here?
The field here at Milo is 930 metres long, and this is a siphon over bank irrigation system with every second metre irrigated with a 3-inch siphon. So Malcolm, tell us about how SISCOweb's going to function with those data sets.
Okay, so SISCOweb takes some of our good evaluation techniques that we've been using for surface irrigation over the years, but it can take the data live from the sensors in the field. The level sensor and the advanced sensors take that data live and do the analysis and then give some results either back to the grower or back to an automation system.
So with the information back to the grower, what is SISCOweb actually sending to the man in the field?
Well, if it's set up appropriately, it could tell the grower when their best time to shut off is to meet their specified target. So if their specified target is to reach the end of the field with a minimum depth, then we can set that up in the system and they can receive a text and then an appropriate shut off time.
That's just received on their phone during the actual irrigation event, is that right?
The evaluation process takes seconds and then that information can be sent directly to the grower, yes.
Okay, so he knows then when to pull those siphons and stop the irrigation process occurring. What is the water level sensor actually used for in that process?
A very important piece of information that we need is the flow rate into the field or into that part of the field, and the water level in that head ditch along with some characteristics can tell us exactly what the flow is into that furrow.
Okay, so those combination of the advanced sensor data and that deceleration of water slowing down in the furrow as it moves further down the furrow, plus the flow rate, is allowing that optimisation to occur?
Yeah, so every irrigation, the advance rate down the furrow could be faster or slower, and it's important to capture that live so we can then do the analysis on what's happening on that day, during that irrigation event.
And what's governing that whole process there with that slowing down or fastening up of that water advance down the field?
Obviously a higher flow rate will cause the water to move faster, but the change in soil infiltration characteristic will change the rate in which that water slows down.
Okay, so that soil infiltration characteristic is pretty important then to actually understand what's going on by the sound of it.
Yeah. Yeah, and soil infiltration characteristic then governs how much is actually applied during the irrigation event.
Okay, so the value to the grower then is understanding from that process what water is infiltrated and what water has run off.
Yeah, from the head level or from a flow meter we can tell how much in gross was put onto the field, but from the sensors and the evaluation we can tell how much has infiltrated and where it's infiltrated along the length and how much is run off.
What do you see as the minimum set of equipment that's actually needed in a field to actually allow this evaluation and this SMS message to go to the grower?
For a good set of data we need probably 3 sensors down the length of a single furrow, and that gives us very good information to run the analysis.